Okay, so let's look at some finite geometric sums. Here's our formula that's already been proved for you. Here's the general term of a geometric sequence. I think I said arithmetic before. I'm looking at geometric. And here's our common ratio, the quotient of two consecutive terms. So in order to find this sum, we need to know the first term, the common ratio, and the number of terms we have. The first term is clearly a quarter. It's kind of hard for me to see what the common ratio is between these two, but I know if I multiply 1 by 2, I get 2. So if I multiply 2 by a half, I get 1. So therefore, if I multiply a quarter by 2, I get a half. So it looks like my common ratio is 2. So the only question is how many terms do we have? So let's use this formula here. So that would be a sub n is equal to, I don't know why I'm just rewriting it. I get 256 equals a quarter, common ratio of 2 to the n minus 1. Multiply by both sides, I get 1024 equals 2 to the n minus 1. I know that this is 2 to the 10th, so that's 2 to the n minus 1. So therefore I set the exponents equal to each other. I get n minus 1 is equal to 10, n is 11. So therefore the sum of the first 11 terms is a quarter, 1 minus 2 to the 11th, all over 1 minus 2. Well, 2 to the 11th, if I know 2 to the 10 is 1024, that means the 11th is going to be 2048. So this is a quarter, 1 minus 2048, all over 1 minus 2. And I just did the rest of this using a calculator. I get 511.75, which is equivalent to 2047 over 4. Our next problem involves a pendulum. I always think of a grandfather clock swinging back and forth. It swings through an arc of 2 feet, so there's our a sub 1. Each successive swing, the length of the arc is 0.9 of the previous, so there's our common ratio. The number of terms we have here is 15 swings. What is the total length that the pendulum has moved? So therefore, our sum of 15 terms would be 2 times 1 minus 0.9 to the 15, all over 1 minus 0.9. And courtesy of my calculator, it would be 15.88217736. Not a very exciting problem. Here we want to find the sum of the first 10 terms. Clearly my first term is 1. What am I multiplying 1 by to get radical 2? Well, that would be radical 2. What am I multiplying radical 2 by to get 2? Well, that would also be radical 2. What am I multiplying 2 by to get 2 radical 2? That would be radical 2 again. So clearly my common ratio is radical 2. My first term is 1, and we want to find the sum of the first 10 terms. So the sum of the first 10 terms would be the first term times 1 minus the common ratio to the 10th power all over 1 minus radical 2. So this is 1 minus, just get rid of this 1 here, it's not very helpful. I'm going to write this 2 as 2 to the 1/2 raised to the 10th all over 1 minus radical 2. So power to a power, you multiply those two, so that would be 1 minus 2 to the 5th, 1 minus radical 2. So the sum of the first 10 terms will be 1 minus 2 to the 5th power is 32, 1 minus the square root of 2, so that is equal to negative 31 over 1 minus radical 2. I'm fine with that answer here. I'm okay with radicals being in the denominator, and I don't care what the decimal approximation is equal to. Just note that we're adding all positive numbers here, so you would think that this sum would be positive. Obviously, this sum is positive because the numerator is negative. The denominator, the radical 2, is larger than 1, so therefore this denominator would be negative as well. Negative divided by negative is a positive, so therefore we'd get a positive sum. And our last problem we're going to look at is we have 3 consecutive terms of a geometric series. What is the sum of the first 10 terms? So we need to know what the common ratio is in the first term, and then we can just apply the formula for 10 terms. So we don't know what the common ratio is, but we do know the common ratio is the quotient of 2 consecutive terms. So let's divide 2k and k. So that gives me a common ratio is 2, so that's part of what we need, but we also need to know what the first term is, and we don't know what k is equal to. So we need to also use that the common ratio is also equal to the quotient of these two terms, which is 5k minus 3 over 2k. So therefore we want to set these, since these two are both from the same sequence, the common ratios must be equal to each other. So we're going to let 2k equal 5k minus 3 over 2k. Cross multiplying, I get 4k equals 5k minus 3. Subtract over 5k gives me negative k equals negative 3, so k is equal to 3. So if k is equal to 3, my first term is 3. My second term is 2 times 3, which is 6. I plug in 3 here, I get 15 minus 3, which is equal to 12. Clearly my common ratio is 2, but we already knew that. My first term is 3, and we're looking for the sum of the first 10 terms. So the sum of the first 10 terms is equal to the first term, 1 minus the common ratio to the 10th power, all over 1 minus 2. So that gives me 3 times 1 minus, we already saw this just a second ago, 1024, negative 1. So this is S of 10 is equal to 3 times negative 1023 all over negative 1. So this is 3 times, this is going to be 3,000. 3 times 23 is 69, so this will be negative 3069 divided by negative 1, which is 3069.